This is the Math SL quadratics exam 1 review. Problem 1. The diagram shows the parabola y equals 7 minus x, 1 plus x. The points A and C are x-intercepts, and the point B is the maximum point. Find the coordinates of A, B, and C. This is not hard if you remember that when you factor a quadratic equation and you get two binomials like this, that the binomials give you directly the zeros of the function, also known as the x-intercepts or roots. So, and they've already given it to you in the factorized form. If you did the investigation with the roller coaster, you'll remember that the roots or the zeros or the x-intercepts here are going to give you the points where the roller coaster hill or valley met the x-axis. So here we're also going to do the same thing. We're going to see where with this equation we're going to meet the x-axis. And the way you do that is you just say, okay, when does this expression equal 0? And it would equal 0 when this is equal to 0 or when this is equal to 0. Now, they're probably not going to be 0 at the same time. So let's check them separately. So 7 minus x equals 0. Let's see what x makes that 0. Well, we'll just use algebra. We will add x to both sides, and that would give us 7 equals x. So that's one of the solutions, 7 equals x. The other solution would be 1 plus x equals 0, and we will subtract 1 from both sides, and that would give us x equals negative 1. Okay? You notice that I always did algebra step by step, subtracting from both sides, adding to both sides, because that is the way to not make any careless mistakes. I'm sure that when you look at this, you can say, hey, this should be 7, this should be negative 1. Just really, really careful when you do that. A lot of times you'll put the wrong sign. Okay? So if one of the x-intercepts is x, 7, and the one of the x-intercepts is negative 1, and we see the parabola drawn like this, we already know that one of the x-intercepts is here and one is here. It's pretty obvious now which one is 7 and which one is negative 1, right? This one would be 7 and this would be negative 1, right? Because one of these is going to be to the left of the y-axis, that would be negative 1. One of these is going to be to the right of the y-axis, that would be 7. Okay? So we already know that the coordinates for C have a 7 in them for the x coordinate, and then remember the x coordinate goes first, and then the y coordinate would just be 0 because we're on the x-axis. So this coordinate would be negative 1 comma 0. Now what about B? This is a little bit trickier, but not that much more. Okay. One thing that you always have to remember, which seems really obvious when you look back on it, but sometimes when you're doing the problem you kind of forget. And that is that once you know the two x-intercepts for a parabola, you already know the x-coordinate of the vertex, because of course the vertex is right in the middle of the two x-intercepts. I mean, the parabola is a mirror image of itself. So if one x-coordinate is a negative 1 and the other x-coordinate is positive 7, then the vertex has to be halfway in between there, which would be, let's see, you could just count, say, let's see, between 7 and negative 1, there's about 8 positions, right? So if I go 1, 2, 3, 4, that would be about x equals 4. Let's see, 1, 2, 3, 4. Oops. See, I made a mistake. So if I counted 1, 2, 3, 4, 7 minus 4, that would be 3. If I counted 4 from negative 1, that would be 0, 1, 2, 3. That would be 3 also. So halfway in between negative 1 and 7 would be x equals 3. So we already have the x-coordinate of the vertex. We just don't know the y-coordinate yet. But whenever you have a function which is totally given to you like this, That's very easy, right? We already know that we can, to get the y value, all we need to do is substitute in the x. The x we know is 3. So what is the vertex? It would be 7 minus 3 times 1 plus 3, which would be 4 times 4 equals 16. So the y value is 16. So it would be, the b value would be 3 comma 16. So I'm going to put here the a point A would be negative 1 comma 0. Point B would be 3 comma 16. And point C would be 7 comma 0. And that's all we needed to know. Oh, they didn't exactly say that B was the vertex, but they did say the maximum point. So you did have to know that the maximum point is also the vertex. Now, problem 2, they give you a standard form quadratic here. They don't tell you anything else about the equation, so it seems like, hey, I don't have enough information to do anything. But then they give you a graph. And with this graph, you can already tell a lot of things. One of the things you can tell is that the vertex is on the x-axis. That narrows it down quite a bit. You see that the parabola opens down instead of opening up. That tells you something. And one more thing is that you see that the parabola crosses the y-axis at this point, which you don't know exactly where it is, but you know that it's below the x-axis, for example. So let's see what they're going to ask us. Complete the table below indicating with a check mark in the appropriate column to show whether each expression is positive, negative, or 0. Okay, so let's see. First it asks us about A. And remember when we did the investigation, we saw that A controls the direction of the parabola, whether it opens up, whether it opens down, whether it opens wide, whether it opens skinny. In this case, it says, it's not asking us if A is big or small, it's just saying, is A positive, negative, or 0? Well, A can't be 0, because if A was 0, that would mean that instead of having a parabola, you would have a line. Because if A was 0, there would be no x squared, and with no x squared, you do not have a parabola, you have a line. Okay? So we know it's not 0, right? So it has to be positive or negative. Well, remember that we know that this parabola opens down. So if it opens down, that means A is negative. Okay? And that should make sense, right? Because if you put in any value for x, and x would square itself, so it would always be positive. If you want the y's to be negatives, like in this case, A would have to be negative. So, yeah. Okay, and then C. Remember what C did. C is basically the y-intercept from the investigation. And if you forget that, then all you need to do is say, okay, well, if I put zeros in for the x's, if I said x is 0, then it would be a times 0 squared plus b times 0 plus c. And what do you know? These two terms go to 0. They disappear. Then we just end up with y equals c. So when x equals 0, y equals c. So that's actually the y-intercept. When x is 0, y is c. So we can see that this point here is at height c. And it asks, is c 0 positive or negative? Well, it's obviously not 0. If c was 0, then it would cross here. It's not positive, it's negative, right? It's below the x-axis, so c is a negative number. So we know that c is a negative number also. Okay, and then we have b squared minus 4ac. Is b squared minus 4ac positive, negative, or 0? That seems like a really weird expression, but remember what b squared minus 4ac is. B squared minus 4ac is the discriminant, which is the part of the quadratic equation that is inside the square root. Why is that special? Because inside the square root needs to be positive or 0 for you to get a valid square root, okay? Otherwise, this is going to be an imaginary number instead of a real number. So the quadratic equation gives you the x-intercepts. And if the discriminant is 0, then you're going to end up with this part being 0. You are going to have repeated real roots. You're going to have the same 0 or x-intercept twice, which means you're only going to have one x-intercept. When this number b squared minus 4ac is positive, then it's going to give you a valid square root, and then you're going to get two different x-intercepts. Okay, so in this case, what do we have? Do we have two different x-intercepts? Do we have one x-intercept? Do we have zero x-intercepts? Well, there's only one point where the parabola touches the x-intercept at the vertex. So we know that the discriminant must have been 0. So b squared minus 4ac must have been 0. Okay? Last one, b. If you remember, the b and together with a tells us where the axis of symmetry is. And in this case, the axis of symmetry is a positive number. It would be, let's say it's like x equals 7 or something like that. We don't know what it is, but it's x equals some positive number. Okay? And so, like, the axis of symmetry can also be written in variables as negative b over 2a. Okay? So we're saying that negative b over 2a is a positive number because from the drawing we can see that the axis of symmetry happens on the positive side. So let's say that this is positive, negative b over 2a. And we do know that a is what? Positive or negative? We already said a was negative. So if a is negative, let's see. If a is negative, then this negative would cancel out with this negative, okay? And then, so would b be positive or negative? Now for b, for this expression to be greater than 0, b would have to be positive, right? Because the expression already starts out with a negative. A is negative. The two negatives cancel each other out, so it's positive. If b was negative, then that would ruin everything because then it wouldn't be greater than 0. So b needs to be positive also. Okay? So b needs to be positive. So when b is positive, a is negative, and negative b over 2a is positive. So then that's why the axis of symmetry is a positive number. Okay? So with this problem, you really needed to understand well the investigation and know that even if you don't get an exact formula, even if you don't have an exact drawing, you still know a lot about whether A, B, and C are positive and negative just from looking at about where the parabola sits.